Hello and welcome back. These will be the notes for 4.5, graphing using slope-intercept form. There is a PDF that you can print out and follow along if you'd like. First thing we want to talk about is what is slope-intercept form. It's a linear equation in the form of y equals mx plus b, where m is the slope and b is the y-intercept of the equation's graph. And that should be apostrophe s. Okay, so y is by itself. We've called this function form before. Now we're knowing it as slope-intercept form because it tells us what the slope of the line is, how steep it is, and it also tells us where it crosses the y-axis, also known as the y-intercept. So look at our equation here, and this 1/3 represents our m, which is our slope, and the plus 1 represents our y-intercept, which is b. So if we want to graph this, all we got to do is find our y-intercept of 0, 1, which would be here. And to find the next point on the graph, we apply the slope of a rise of 1 and a run of 3. A positive 1 is up 1 and over, up 1 and over 1, 2, 3. And there's our next point. We can do it again, up 1 and over 1, 2, 3, and there's our other point. And if we wanted to find points on the other side of our intercept, we could just go down 1, which is negative, and left 3, which is negative, and negative over negative would still be positive. So we can go down 1 and left 1, 2, 3. And we've got enough points there. All we got to do now is draw our straight line as best as we can. And that's how easy it is to graph from slope-intercept form. Example 1, identify the slope and the y-intercept of each equation. Well, number 1 is really easy. It's already in slope-intercept form, so we would say that m is equal to 5. So our slope is 5. We could call it 5 over 1 if we'd like. And our y-intercept, also known as b, is equal to negative 3. That number out in front, or that sign out in front, is important. It is negative 3. Question number 2 is in standard form. So we have to rewrite this in slope-intercept form. So we need to isolate the y value. So the first thing we're going to do is move the 3x over. So we have negative 3y is equal to negative 3x plus 12. And then we're going to divide the whole thing or multiply the whole thing by negative 1/3. That turns this back into a positive 1. 1y, negative times negative is a positive, 3 times 1 is 1x, and positive times a negative is a negative, 12 times 1/3 is 4. Now we don't need this 1 out in front, but some people like to have that there so they can clearly see what the slope is. So for number 2, the slope is equal to 1, while the y-intercept is equal to negative 4. We're going to do the same thing over number 3. It's in standard form, so I have to rewrite it into slope-intercept form. So I'm going to move the x over first. So 4y is going to equal x, let's change that to x plus 6. And to get rid of this 4 here, I'm going to times by the reciprocal, which is 1/4. And that gives us a positive 1y. X times a fourth is 1/4 x. Remember, there is a 1 out in front of x. Plus 1/4 times 6 is 6/4. So we are in slope-intercept form, so we need to identify the slope. Slope would equal 1/4. And our y-intercept, even though it's a fraction, is still the y-intercept, is 6/4, and you can go ahead and reduce that. Divide by 2, we get 3/2. It's not the prettiest to graph, 3/2, but it is the y-intercept, 3/2, and the slope is up 1/4, rise over run. Identify the slope and y-intercept of each equation. I think we just did that. I think what we're asking to do here is graph. We've already seen an example of graph. Okay, so first thing I'm going to do is identify the slope. well, the slope is equal to 5, which is 5 over 1, because I'm going to need that for my rise and run on the graph. And my y-intercept is -3. So we're going to plot the y-intercept first, which would be down 1, 2, 3. And to find the next point on the graph, we're going to go rise 5 and run 4. So from this point here, we're going to go up 1, 2, 3, 4, 5 and over 1, and that gives us a point there. And I can do it again, up 1, 2, 3, 4, 5 and over 1. And if I wanted to find points on the other side of the intercept, I can go down 1, 2, 3, 4, 5 and over 1. And as you can see, we have a slope of 5, which is a very steep line. And just use a straight edge. I'm just free-handing this. And that would be our graph. Example 3, escalators. To get from one floor to another at a library, you can take either the stairs or the escalator. You can climb stairs at a rate of 1.75 feet per second, and the escalator rises at a rate of 2 feet per second. You have to travel a vertical distance of 28 feet. So it sounds like there's 28 feet between floors. The equation models the vertical distance, d, in feet, you have left to travel after t seconds. So we've got two equations, distance for both. The first one, stairs, is -1.75. Now I'm guessing that's because they are going from a higher floor to a lower floor. So they're going down, starting at an elevation of 28 feet. And the escalator is the same thing, only it's got a different slope. Notice that the slope on the escalator is -2, so it's going down faster than you're stepping down, which means you should get down to the next floor faster. So if we graph both these on the same grid, or the same coordinate plane, and you might notice that we're really only looking at quadrant 1. Most real-life scenarios, we only look at quadrant 1. By the time we get down to the ground floor, which is 0, the time value over here will tell us what time it takes us to get down there. You can see that it took 16 seconds to get down by stairs, and it took 14 seconds to get down by the escalator. So how much faster do you get down to the first floor or the next floor by taking the escalator? Well, 16 minus 14 is 2 seconds faster. Next concept is parallel lines. Parallel lines are really easy. They're simply two lines in the same plane that do not intersect. An important feature about parallel lines. You might want to double or triple underline this here. Very important. Parallel lines have the same slope. It's that same slope that prevents them from intersecting with each other on the graph. So let's go ahead and calculate point A. What is the slope of point A? Well, from point A, we're going to go up 1 and over 1, 2, 3. So that's going to be a slope of 1/3. Point B. Point B goes up 1, 2 and over 1, 2, 3, 4, 5. So 2 over 5 is that slope. Point C is up 1, 2 over 1, 2, 3, 4, 5, 6. 2 over 6. So the lines up here that are actually parallel to each other are A and C. A and C are parallel because they have the same slopes. Even though the red one looks like it may not intersect the blue one, eventually it will because it does not have the same rise and run. Example 4, determine which lines are parallel. A, B, or C. Again, we're going to calculate the slopes. So A has a rise of 4 minus 2, which is 2, over 3 minus -1, which is 4. We can call that 1/2. B has a rise of 4, and a run of 2, which is 2 or 2 over 1 if you want to call it that. And C has a rise of 4 over a rise of 8, and that is 1 over 2. And since these two have the same slope, A and C are parallel because they have the same slopes.